you can start.
Okay, thank you. Hi everyone, and thanks for being here at our talk Custom View with MotionLayout. So this is the last talk before the final session. We know maybe you are tired, but try to hold on. And after these 2 days of news on Android, we hope to bring an interesting talk based on our experience. Before starting, we would like to thank the Droidcon Turing organization to give us this second opportunity after the one in 2019. And we hope to be able to have a new session maybe next year and live. Okay, here quickly the agenda of the meeting. So no wasting time here, but we can see quickly what we are going to tell. So we tell about us, so a short presentation about us and our company. So we go to the introduction, so why we started experimenting with custom view and with the motion layout. So then we pass to the solution analysis, so we can see how we can analyze and which technical solution we analyze to have the final choice. And then the main chapter about the talk, the motion layout choice. So here we will see the technical details, and to conclude the talk, we see pro, cons, conclusion, and the Q&A session. Let's start with the presentation. My name is Marco Balanzino, and I have about 4 years of experience in a mobile project in financial sector. And after starting my career as an Android developer, today, I mainly deal with project management. So I working and I play with PowerPoint, Excel, and this similar tools. So in my free time, I still like to deepen and improve my technical knowledge about Android and other technical environments. So my mate, Alessandro Rota, has been working on Android projects for about 3 years, and he is our technical leader and architect, who is in charge of bringing innovation, improving our apps, follow the guys that working on our apps. Then here are some details and some pills about our company. We are from HighRiskCube, a reply group company. HighRiskCube provides some consultancy services and innovative solutions, so especially in financial industry. And generally, we're working about everywhere in the IT field. So we're working on front-end web, on mobile native solution, on microservices, architectures, and so on. Before going to the heart of the discussion, a few numbers about our company. We are a company in cost and grow with a profit, with an average profit of 16-20%. We have just under 300 employees. We have a young and talented team. So the average age is 29 years old. So in this slide, you can also see some of our main customers. So Intesa Sanpaolo, CheBanca, Banco BPM, and so on. That's all large banking groups in Italy, and not only Italy. Then now move on to why we start to investigate and use a custom view with motion layout. So it all started from a specific request from one of our customers for the creation of a complex graphic component to be used in different points, in different contexts on our application. So the solution to be implemented had to be centralized, highly reusable. So let me tell you how all components should be developed. And that component also had to be easy to integrate, since the entire development team use it inside the app. Then here we have some details, some points or requirements on which we have focused for the realization of the solution. So the solution must be reusable and versatile. So we need to have a versatile graphic component. The layout that which we call during the talk HALFMOON need to have an arc view, a layout with an arc view, and a specific layout inside the arc view. Then we need to have some different animation animation on the arc when we are in the scrolling phase. The arc increase and decrease the cube based on the scrolling. We need to have a large title animation, similar or like iOS, also by managing fade in, fade out, and small title to large title animation. And then we need to have a magnet effect in scrolling phase. And then final, we need to have the possibility of insert a complex graphic component inside or near the half moon. So here we have an example about our layouts, our requirements. So as you can see, we have an arc view, and inside the arc view, we have a carousel with some card account. And when we scroll up, the card disappear with the fade out animation, the large title, so going to the toolbar, and then we collapsing the card by transforming, by having a little description about the bank account. Then under the arc view, we have another layout that represents the transaction about the bank. Okay, before moving on the choice and the technical details, let's make a brief introduction to our needs. So we need to have, in order to respect the customer request and the timing and the fact that we develop a cleaner technical solution, we had to be a quick solution to develop, to deliver on release time. So we need to have a solution fast to develop. We need to have an easy component to integrate through the app and usable by all developers with different experience and with different skills. We need to have a flexible component to be able to satisfy any graphic changes. And finally, the solution had to be built by using only stable libraries and then by excluding beta components. So go on to the next slide. We analyzed the three approaches that we studied, that we analyzed. So we analyzed the coordinator layout, but it's very interesting component, but it's very complex to use. And the study of this phase, the study phase required a lot of time. So the learning curve is too long, and we have not much time to develop the component. So therefore, it was excluded as a solution, but it was too easy to integrate, reusable, flexible, but not fast to develop. Then Jetpack Compose. It's fast to develop, easy to integrate, reusable, flexible, but when we create a HALFMOON component, it was still in beta version. Then now we will study if the Jetpack Compose simplify our life and our developments, but in the past we cannot use that. So MotionLayout, the final choose, is easy to use even for the creation of very complex layouts. So just by reading the documentation, you can understand that it's very simple to use. So it is the perfect choice for requirements, times, and stability. The fact that, in addition, the fact that MotionLayout, Motion extends the constraint layouts, allowed us not to insert new libraries in our app. Now, Alessandro, we will explain all the technical details to you.
Okay, so I'm Alessandro Rota, and I work together with Marco on the development of these custom components. So before starting to talk about the custom view itself, I would like to make a brief introduction on MotionLayout. I'm sure that most of you already know a lot about MotionLayout, but maybe some of you don't know the basics of how it works. So I think it's better to make a brief introduction to be ready to understand what we will explain about our custom view. So let's start. And what is a MotionLayout? A MotionLayout, as the documentation of Google says, is a sort of mix among three components that were already present in the Android framework, that are Property Animation Framework, Transition Manager, and Coordinator Layout. Property Animation Framework has this idea of setting an initial and final value for a property and interpolate between an initial and final state for that value. And that's similar to what MotionLayout does, but with property animation framework, you have to do that by code. So it's not declarative, while MotionLayout is declarative. So you can set two scenes, an initial and final scene by XML, and interpolate between two states. And about Transition Manager, well, Transition Manager has, again, the idea of starting and ending scene and the interpolation between these states, but it can be used on layout attribute and not property. So MotionLayout can also handle properties. And last, coordinator layout is a very powerful view group. It's a sort of superpowered frame layout. It allows you to handle complex animations with behaviors, anchors, and it supports seekable transitions. Seekable transitions are transitions that are triggered by the touch of the user. So you can, for example, swipe up on a view and start an animation with that trigger. And this is exactly what MotionLayout allows us to do. And so the only, I think, drawback of coordinator layout, as we said before, is its steep learning curve. It takes a lot of time to understand how it works. And in the moment in which we had to realize this custom view, we didn't have so much time. So in our mind, the best solution was the MotionLayout that is fully declarative and allows you to provide very complex animation with simple code. Well, as I said before, the idea of MotionLayout is to interpolate between an initial and final state. So you can define your layout. For example, in an activity, you can have a layout inside the layout folder, and there will be another layout that is a motion scene, that is an XML, and it is in the XML folder. So let's go and see what are, let's say, a very easy implementation of MotionLayout. I just use the Google example. So if you already see you have already seen this layout, don't worry, it's the same, because we want to focus on our view, and that's just a simple example. So first of all, in your activity XML, you have to define a motion layout with a simple view inside of it. In this example, it's a square, a red square. And an important parameter is the layout description. That is a pointer to the scene, to the other XML that describes the animation. So the animation is something like that. We have an initial and final constraint set. A constraint set is a sort of resting state, a state in which the view can rest, and allows you to set many different parameters. For example, the constraints, but not only that. You can also set many attributes of the layout, for example, alpha, visibility, elevation, rotation, scale. There are a lot of them, and you can also set other attributes that are called custom attribute, for example, the background color of the view itself. And the motion layout will, by default, interpolate from the initial to the final state. So another parameter that can be set in the motion scene is the transition that, let's say, allows you to configure some parameter on the animation itself. For example, the duration of the animation in milliseconds, the touch anchor ID, and the touch anchor side, that are the ID of the view on which you can swipe to trigger the animation, because as we said before, this motion layout supports seekable transitions, and a drag direction. That is the direction in which you have to swipe to start the animation. In this case, is drag right. I think it's important to talk also about keyframes. Keyframes are a sort of intermediate states. So they are states your view goes through during the animation, but doesn't rest. And that's the difference between the constraint set and the keyframes. Keyframes allow you to make very powerful animation. So you don't have just to interpolate linearly from one state to another, but you can have a very dynamic animation. In this example, we added a key position keyframe, and that allows you to set at a certain frame position. In this example is 50. Frame position go from 0 to 100. 0 is the initial state, 100 is the final state. So 50, we are basically saying that in the middle of our animation, that square must be placed in a certain position. And there are not just key position frames, keyframes, but also key attributes. So you can set the value of an attribute, for example, again, visibility, alpha elevation, whatever, at a certain frame position. And as we will see later, that's exactly what we needed for our animation. So that's the end of the introduction, and let's deep dive on the HALFMOON view. That is the name that we decided to give to our custom component, HALFMOON, because you probably noticed that there is that curved bottom edge on the toolbar. So that's the origin of the name. This is the final result. So we basically have two states, an expanded and a collapsed state. In the expanded position, you can see in a credit card, the image of a credit card. And in the collapsed position, there is the name of the card and the amount on the card itself. Under the toolbar, there is a list of transactions. But I think the difficult part and the part that required to us to make a custom view was that we needed to the view to be flexible. I mean that in place of the list of transactions, the credit card, you can place whatever you want inside your views, because we had many use cases in our application in which the kind of animation was the same, but the content inside each of these containers was different. So we needed to make to reuse, let's say, the animation logic and at the same time provide flexibility on the content that was to be placed inside the view itself. So before deep diving on how we approach this container necessity of our view, let's see how we as a developer who uses his HALFMOON view, whatever we have to do. We just have in our layout to place the HALFMOON view, that is a view group like linear layout, for example, and there are many attributes that we can set on the HALFMOON view. In this example, we try to show up most of the attributes that you can set. So there is, our background supports a gradient, an oriented gradient. So we can set the colors of these gradients, the position of the gradient, the angle, and we can also set the title and the color of the title itself. And we can also decide if you want to translate our, in our case, it's a credit card, but it's actually whatever we want. We can translate it along the y-axis. So if we don't want our credit card to stay inside the arc view, we can set a sort of offset on the y-axis. And it's very easy to use because we use the container-based approach. What is a container for us? A container is a view. It's basically a linear layout that is present in the HALFMOON view, in which we will add at runtime whatever the user wants to to be placed inside each container. There are basically 3 containers in our view, and they are the red, green, and yellow container. The red container is the expanded container, so the view or a set of views that appear when the state is expanded. The yellow container is the collapsed container, so the container that appears when the view is collapsed. And the green container is our bottom view container that is usually a list, but actually can be whatever we want. And it's the element on which we can scroll to trigger our animation. And on a code point of view, we implemented that with Android tags. So the user inside the HALFMOON view can set these views. They tag the view with a specific tag, and inside the HALFMOON view, we retrieve that tag and place that view inside the correct container. So in the case, we will always focus in the next slides on the expanded container, but for the other containers, it's absolutely the same. And for the expanded container in this example, in the activity layout, there is a linear layout. The code that you can see here is inside the MotionLayout. It's the direct child of the MotionLayout. And the linear layout is tagged with the specific tag for the expanded view. So this was the code of the activity layout. Inside the code of our custom view, we override the addView method. The addView method is a method that is called for each direct child of our view as soon as it is, say, inflated and put inside the view hierarchy. So we get the view with that specific tag and place it inside the expanded container view. That is a view, the red view that you can see in the example. And that's the way we achieve the flexibility that our HALFMOON view has. So here I try to represent the initial and final states of the view. I know that my drawing skills are very bad, but I did my best, and I hope that it's clear that there are actually the main views, the most important one are 4. There are many more, not many, there are some more views, but to be clear, I decided to just keep this 4 view in the drawing. So there is the expanded container, the collapsed container, the bottom view, and the arc view, that is the view that contains the background. In our case, it was a light blue background, but it can be whatever color or gradient we want. So there are actually many constraints. On the left, you can see the initial state. On the right, the final state. But if you look carefully, there are actually just 2 constraints that changes from the initial to the final state. There is the constraints from the arc view to the expanded container that in the initial state, it's exactly from the arc view to the expanded container, and in the final state goes from the arc view to the collapsed container, and that's what makes the arc view collapse. And the other constraint that changes is the expanded container. Initially, the top of the expanded container is attached to the top of the MotionLayout of the parent, and in the end, the bottom of the expanded container is attached to the top of the motion. And that's what allows the expanded container to go up during the animation so that the collapsed container can be visible. So here you just see the code that I just described. Again, we focus on the expanded container. For the other containers, it's the same. We have an expanded constraint set and the collapsed constraint set that are our initial and final state. In the initial state, there are some constraints. In the final state, there are other constraints, and that's what allows the expanded container to go up. Another parameter that I didn't mention before is the alpha. In the beginning, it's 1, so the view is fully visible. On the end, it's 0. And that's what allows the fade out animation during our transition. So the peculiarity of our fade out was that it was not to be achieved in a linear way. I mean, we don't want to go from 1 to 0 in from frame 0 to frame 100. We want that in the first 30 frames the alpha is 1, and then it rapidly decreases until 0, and it reaches 0 at frame 70. And to achieve this, we just added 2 key attributes that set the alpha value to 1 on frame position 30 and on 0 on frame position 70. And that's another example of the ease of use of MotionLayout. So we said before that we needed to achieve a magnet effect. A magnet effect is, on a technical point of view, is what is called the auto-completion. So if we start our animation, then we stop swiping and lift our finger off the screen, and the percentage of completion was less than half, we have to reverse the animation and go back to 0. If the percentage was more than half the animation, we have to auto-complete the animation and go automatically to 100. That I think was not so trivial to achieve with other components, but with MotionLayout it's very, very easy. We just have to add the one parameter that is OnTouchUp and set it to autocomplete. And actually, this is I think the default value for MotionLayout. So we don't even need to set to write that one line of code, because by default MotionLayout will behave like that. And that was very, very useful for us. And I think that was one of the main reasons why we decided to use MotionLayout. Well, so far, so easy. Yeah, MotionLayout makes a lot of things easy, but not everything. I mean, we had not just to add some keyframes to achieve some particular effect, but in some cases that was not enough. I mean, we had to implement a sort of animation that when the bottom of the large title disappears, starts the fade in of the small title. The small title is the title that you can see on the left of the search button, the title Bill's cards. And to achieve this kind of effect, we had to be very precise, because text view are let's say very difficult, because they always have a sort of padding from the actual text to the border of the text view itself. So it was very hard to set a frame position and achieve that on a certain frame position, because we don't know exactly at what frame position the large title will disappear completely. So to achieve this kind of effect, we used the onLayout change listener. The onLayout change listener is invoked every time the layout bounds of a view change due to layout processing. So we added this listener to the large title, and at each frame in which the large title changes its position, this listener is triggered, and we can update the alpha of the small title, and also update the curvature of the arc, because it was probably not so evident, but when we collapse the toolbar, also the curvature of the arc slightly changes. Well, one last note about life cycle. we tried to make this view as performant as possible. And to do that, we first of all, we studied the view lifecycle. So a brief introduction about view lifecycle. First of all, the constructor is called. In this method, we get the attribute, the custom attribute that you have seen before, that are, well, basically the title, the background colors, the offset, if there is an offset of the expanded view, and so on. After that, well, the add view method is called. That view is called for each direct child of our motion. So in this case, on this callback, we inject the view into the containers. After that, on attach to window is called, and then on finish inflate is called. At this point, all the view have been inflated, and we are able to set the background, even if some view sizes with heights have not been measured yet. We are already able to set the background according to our implementation. And so there is some quite heavy computation to compute the gradient, and we try to do that as soon as possible to make the view performant. So that the next callbacks that are basically on measure, on layout, on draw, basically do nothing in our case. And in this way, we try to stay as performant as possible. So that was the implementation of our component, and I think it's useful to look back and understand what was good and what was not so good in our implementation. As in every case in engineering, there is a trade-off. So if you decide, well, if you make a decision, there are good and bad aspects. And I think that the good things about this decision was the ease of use for the consumer. I mean, for the activity, for the fragment layout that wants to use our view, because they just have to place the HALFMOON view in the XML, tag some view with some specific tags, and everything is done, is given out of the box by the HALFMOON view. So it's very easy to create layouts with this component. And another good, another pro, let's say, of the view was that a complex animation was realized with a very small amount of lines of code. Our custom view is about 400 lines of code. Most of them are setters and getters for some public properties, and the code for the animation is very small, and it's mostly done in the motion scene XML. So that on a certain point of view was a good thing. And another very good thing was that built-in support for magnet effect and auto completion. So as I said before, probably doing that using some other component was not so easy. With MotionLayout, it was given just for free. And these are the good things. But let's go to the negative side. We used this container approach that was easy to use, but not so performant, because we added a layer of, let's say, a nesting in our layout, because well, we added this container, and so you have this container. Inside the container, you can set another view group. So this container is one more nesting in our layout. And about performance, having a two-nested layout is never a good option. But in our case, the loss in performance was very low, and the improvements on the speed in development for the consumers of the view was very high. So we decided to make this trade-off. And as I said before, some part of the animation were not actually achieved with MotionLayout. So motion layout is very flexible, allow you to do a lot of things, but some specific kinds of animation were not possible to achieve. I don't want to say it was impossible, but at least we were not able to achieve that in an easy way with motion layout. And last, the animation was defined in XML. That's good things because there are not so many lines of code, but on the other side, the custom view is hard to extend because, I mean, if you want to extend this component to add some behavior, you basically have to rewrite the motion scene, and you cannot just add it to, well, you can add it to the actual HALFMOON view, but that's not the best option because well, if in 90% of cases you just need the basic HALFMOON view, it's not the best to have to add the additional feature to the main components. It's better to be based on extension, and that's not so easy to achieve with XMLs. So that was the end of our talk. And so if you have any offline question, offline or even just now question, we are here for that. I hope that the talk was interesting.